This is the objective of this video. We have to connect the PC to the Bluetooth module, and then we have to switch on and switch off these LEDs, both in Arduino and in STM32. We will launch it and the application will allow us to connect. Before connecting, the Bluetooth red light blinks fast, and after connecting the Bluetooth module to the PC, it blinks twice every 5 seconds more or less. We can send 0 from the PC to the Bluetooth module, and when the programs in the microcontrollers receive 0, they have to deactivate the LEDs. And when we type 1, then the microcontrollers receive this character and the LEDs are switched on. These are the steps that we have to follow to achieve this. First, we have to supply the Bluetooth module with 5 volts. Then we have to connect the module as a Bluetooth device to our PC and pair them. We should write down the name of the COM ports. Then we have to check the hardware in loopback mode. This means that we will type a character, and the same character or signal or message that is received in the slave is transmitted to the master. Logically, the master can compare the transmitted message and the received one and check that they are the same. We are going to do that using an available Bluetooth commercial application. And also we are going to use TeraTerm, which is a generic serial COM application which is not specific for Bluetooth. Next, we are going to show how to codify the application for our PC, which will be the master. And then we have to codify the application for the microcontroller, which will be the slave. First, we are going to do the program for the Arduino, and then for the STM32. And now we are going to codify the application for the PC that will be the master. As previously mentioned, we are going to forget about Bluetooth, and we are going to codify a program to communicate with a device through a simple serial communication. The code is a version of the code that you can find here in this web, but I didn't manage to make it work in console mode, so I modify it by translating to a Windows Form application that is a bit easier for me. The best thing is to create a new project and copy the code. I made it in Visual Studio Community, which is free. This is the one that I made. We can open it and try to compile it and launch it. With a bit of luck, it will work. If not, don't worry, I can tell you how to create your own project and copy the necessary lines. First, you should select the code in the file form.cs and copy it. Then create a new project of type Windows Form application, type a name, and write down this name, or remember it, which is test_bt. And now we get into form1.cs, select all, and paste the previously copied test. We can't forget to replace the namespace by test_bt. And also, we have to remember to probably modify the name of the COM port. Probably yours won't be this, but the other one that you saw in previous steps, so you must change it. And after these 2 modifications, we can launch the application. This small window will appear, so I can connect, but before connecting, we can check the red light blinking fast. And now I click on connect. This message, connecting, should appear. And when it turns to close, this means that it's connected. We go back to the real device. I can see the red light blinking twice every 5 or 6 seconds. This means that it's connected and paired. I can send something, and I should receive the same in loopback mode. This is what I sent, and this is what I received. And the application for the master is done. So let's begin with the first step. The Bluetooth module HC06 has 4 pins, 2 for the 5-volt supply, transmission and reception. Please take into account that TXD in the module has to be connected to the reception pin in the microcontroller, and vice versa. This must be connected to 3.3 volt pins. In the case of RxD connected to the transmission pin in microcontroller, please have in mind that for some microcontrollers, the high level of outputs can exceed 3.3 volts. The 5 volts supply can be obtained from the microcontroller. Well, it depends. In fact, it will be better if you obtain it from an external supply. Here, I have my Bluetooth module, and when powering on, we will see a red light blinking 3 or 4 times a second. And let's see how to connect it to my PC and how to pair them. I can type Bluetooth in Cortana, and here in Bluetooth configuration and all devices, select Add Bluetooth. After a while, I should see my Bluetooth device, and when clicking, it will try to connect and tell me to introduce the password to pair them. It should be 1234. After that, they are connected and paired themselves. Now we can check that we have the serial communication port enabled. We can select more Bluetooth options and then COM ports. And we will see COM10 and COM9. If you are not sure which is the right one, just write down both of them and then you will be able to select the correct one. Another way to check the ports is typing in Cortana Device Manager, and then in Bluetooth we can select our device HC05. Good, but we can't see the associated port. It is better if we move to ports down here, and again COM10 and COM9 appear, but they have no indication of which one to select. Well, it seems that we have the module Bluetooth connected through a serial port, and once that we have achieved that, we can forget about Bluetooth and treat this device as a simple traditional serial device. Now we can codify the application for the microcontroller. You can codify it for any microcontroller. I have done for the Arduino and also for STM32. In fact, I prefer the STM because it is powerful, it's more powerful and also more economic. However, I usually begin to implement my applications, mainly the hardware, with Arduino because it is easier to find documentation, libraries and same examples that you can use to give your first steps with very few lines of code. So let's begin with Arduino. You must have in mind that you must connect the TX pin in the Bluetooth module to the RX pin in the Arduino. I have chosen serial 3, whose RX pin being the 15. And this is the real connection. I have used a DC-DC converter at the right to limit the voltage to 5 volts. With the exception of the supply cables, only one cable appears, that is the green cable from TX in the Bluetooth module to the RX in the Arduino board. And now, if we launch the application, we can connect the computer to the Bluetooth module. When it is connected, the light will slow down. And now, if I set something, for example 1, the LED toggles. If we set something different to 1 and 0, nothing happens. And if I finally send 0, then the LED is deactivated. The code is very simple. In the step, we must set up the serial communication. And in the loop, I only have to read the characters and proceed accordingly. In addition, I can also use another serial communication via USB to see what receives the microcontroller. And finally, we are going to codify the application for the STM32. I'm going to use a Nucleo STM32 F103AB. Its pinout is shown here. I'm going to use an external supply, so I must connect positive and negative to here and here. These other are the reception RX and the transmission TX. It costs around 10 euros or $10, so it's very economic. I have also tested it with this other. It's embedded in a smaller board and costs around 2 or 3 euros. and it's a very good option as well. For the very first test, I think it's better to use the 5V supply coming from the USB. After the first test, you might prefer the external supply, and you must use these pins to supply the board. In this case, you should change the position of a jumper and move it to the right, well, at the right as you look from the USB connectors, as appears here. To start with your project, it's better to use this program, STM32 Cube MX. It has a very good wizard that makes all the configuration tasks for you. Here you can see images from this application. I will use USART1 instead of USART2. So let's launch the application, and I'm going to start my project from my board. Selecting Nucleo 64 and this 103. Start project, yes. Then I can give any name and save it somewhere. Maybe you see this message. By now, press no. Now I will configure the USART1, and the only thing that I have to do is select asynchronous, and these pins A9 and A10 will be selected, corresponding to transmission and reception for USART1. I must also establish the speed, 9600, and everything is okay. Finally, I have to enable the interrupt. Let me check, did I make everything? Asynchronous, speed, and interrupt, okay. If you go to Project Manager, you can select the ID of your choice. I prefer K-Microvision. After that, I can go to this tab, and I usually choose this option because I prefer not to generate a lot of files. And after everything is properly selected, I can generate the code. The program allows me to open the project, and I have my project here. And in the main, the only thing that I have to do is modify this file. I must always write between user code begin and user code end. If I do so, and modify something in STM32 Cube, I will not lose my modifications. I can go to this slide, where the code is summarized. I can copy these lines that go before the main function as global variables, and these other lines corresponding to the main loop. And finally this part, corresponding to the code to be performed when a serial interruption appears. This interruption will be provoked by an incoming message through USART1, always respecting that the included code must be between user code begin and user code end. Now we can compile, and after a while it should be compiled without errors. And now I should transfer into the microcontroller. Previously, I have to connect it via USB. I can download it, and after that, I have to restart it by pressing the reset button. The application is still open. It's blinking fast. I can connect, it's connecting, and after a bit, it is connected. I can type 1. And when it is received, the green light is active. If I send 6, for example, nothing happens, and if I send 0, it turns off. And finally, I can close the port. You can find all the material in Megatran.com or in Megatran.com HC05. Thanks for watching, bye.